In this lesson, we're going to be solving linear equations in one variable. And a linear equation is one that has an x to the 1 term. We typically don't write that exponent of 1, but basically it has a term with an x that doesn't have any other exponents, no x squareds, no cubes, no square roots, just a linear x to the 1 term. So let's first take a look at a handful of equations and see if we can identify which of the following are linear. In part A, there's the only term with x. There is no exponent other than that imaginary 1, so part A is an example of a linear equation. In part B, the term with an x has an x squared, and so that is not a linear equation. Part C, I have lots of terms with x's, but each of those terms is linear. Each of those terms does not have an exponent. Part D, I have a couple x terms, and there it is, the one on the end, the x cubed, is a nonlinear term because of that exponent of 3. So that is not a linear equation. And part E is also nonlinear, and that's because of the square root. So we're going to be focusing on linear equations like you see in parts A and C, and our goal is going to be to find solutions to solve these equations. So before we get started with solving, let's talk a little bit about how we know if a number is actually a solution. What does it mean to have a solution to a linear equation? A solution is a number that makes the equation true when it's plugged into that equation. So in example 2, I have the equation 4x minus 9 equals 2x, and I want to know, is x equal 3 a solution? So what I can do is I can actually take that x equal 3 and plug that in to the x's in the equation. So that gives me 4 times 3 minus 9 equals 2 times 3. So I just replaced all of the x's with 3's. And then I'm going to do the arithmetic and see what I get. 4 times 3 is 12. 12 minus 9 is 3. And then on the right-hand side, 2 times 3 is 6. Oh, but 3 does not equal 6. So because I got a false statement here, 3 is not equal to 6, the answer to the question is no, x equal 3 is not a solution. A solution is something that would work. That gives you a true statement. So how do we find solutions? We're going to learn a couple different properties of equality. And the first property is the addition property of equality, but it's actually saying that you can add or subtract the same number from both sides of an equation. And this idea from both sides is really important. We're going to learn that the main idea behind solving equations is whatever you do to one side, you have to do to the other side. Now, the goal of solving an equation is getting the x by itself. So if we look at example 3a, x minus 4 equals 24. I want the x by itself, so I have to get rid of that minus 4. The opposite of subtracting 4 is adding 4. And so this property says I am allowed to add 4 to both sides of the equation, and it doesn't actually change anything. So now on the left-hand side, the minus 4 plus 4 add up to 0, and I'm just left with an x. And on the right-hand side, 24 plus 4 is 28, and that's my solution. And the way that you check your answer is you take your original equation and you plug your solution in for x. And so in this case, if x is 28, 28 minus 4, that definitely does equal 24. And so I know I've done the problem correctly. So we're allowed to add the same thing to both sides. And if we have a positive number we want to get rid of, like in example B, I want to get rid of that plus 6. To get rid of that plus 6, I can actually subtract 6 from both sides. So I always want to do the opposite of what I see. It's a plus 6 that I'm getting rid of, so I'm going to subtract 6. And I have to do that to both sides of the equation. That gets rid of the 6 on the left-hand side, and I'm just left with the m. And minus 14 minus 6, that is minus 20. Okay, so we're allowed to add or subtract the same thing to both sides of an equation. Now, the multiplication property of equality says that we are allowed to multiply or divide the same number from both sides. And so we can use this if we want to undo the operations of multiplication or division. So if I take a look at example 4a, I have the equation 5x equals negative 35. This 5 is actually being multiplied by the x. It's 5 times x equals negative 35. So to get rid of that 5, the opposite of multiplying is dividing. So I'm going to divide both sides by 5. 5 divided by 5 is 1, and that leaves me with a 1x equals negative 7. Now, example B is actually a very similar equation, even though maybe it doesn't look like it at first. That negative x means we have a negative 1 times x. Remember that coefficient of 1 is something that we usually don't write down. So a negative x is actually a negative 1x. To get rid of the negative 1, I'm going to divide both sides by negative 1. Same thought process as above. Negative 1 divided by negative 1 is positive 1, so I get a positive 1x. Oh, and 7 divided by negative 1 is negative 7. So if we want to get rid of multiplication, we can do that with division. And if we want to get rid of division, so this next example, I'll just rewrite the equation. We have x divided by negative 3 equals 7. The opposite of dividing would be multiplying. So I can actually multiply both sides by negative 3. The negative 3's on the left cancel out. Negative 3 divided by negative 3 is 1. So I'm left with 1x equals negative 21. Now, of course, you can always check your answer. If you take the negative 21 and you plug that into the original equation, negative 21 divided by negative 3, yes, that is equal to 7. Now, as the equations get more complicated, we might have to use a combination of these steps. We might have to use addition, subtraction, multiplication, division, as well as some things that we learned in the previous lesson. And so I have written out in the notes some general strategies for solving equations. And so just to kind of quickly summarize, I think this will make more sense as we do some examples. The first thing we're going to do is simplify each side. That is distribute and combine like terms. And what I mean by distribute is get rid of parentheses. This is what we learned in that previous lesson. Step 2, we're going to use addition or subtraction, basically to move terms around. The main idea is we want the x's on one side and everything without x on the other side. And then we always finish the problem with multiplication or division to get that x completely by itself. So let's see how this works with some examples. In example 5a, step 1 is simplify. There are no parentheses. There's no simplification to do. And so I move to step 2. Step 2, we want to isolate the variable term. We want all the c's on one side of the equation. So that 7c needs to be by itself. That means I have to get rid of the plus 6. The opposite of adding 6 would be subtracting 6. So I'm going to subtract 6 from both sides. That gives me just a 7c on the left. And 62 minus 6 is 56. So now that the variable term is by itself, we want to get the c by itself, so we have to get rid of that 7. And so to finish, I'm going to divide both sides by 7, and that gives me 8. C equals 8. Example B is kind of similar. Step 1 is simplify, but there are no parentheses, nothing to do there. And then the idea is I want all the variables, all the y's on one side. And so I'm going to try to put the y's on the left. So that minus y needs to move over to the left, and this minus 1 needs to move over to the right. So the idea is I want to use addition and subtraction to kind of rearrange things so that the y's are on one side and the things without y are on the other side. So I'm going to start by putting the y's on the left. So I have to take this minus y and get rid of it or move it to the other side. The opposite of subtracting is adding. And so I'm going to add y to both sides. That gets rid of the y on the right. And on the left, 2y plus 1y is 3y. I still have the minus 1 equals 8. Now I need to take this minus 1 and I want to move that to the right. I want to get rid of that minus 1. The opposite of subtracting is adding. So I'm going to add 1 to both sides. On the left, I just have a 3y left over. And on the right, 8 plus 1 is 9. So to finish, I want to get rid of that 3. It's 3 times y. So I'm going to divide both sides by 3. And I am left with 1y equals 3. 9 divided by 3 is 3. If I wanted to check my answer, I would just go to the original equation. I'd replace all the y's with 3's. And if I do the arithmetic, on the left-hand side, I get a 6 minus 1, which is 5. And on the right-hand side, I get 8 minus 3, and that is also 5. And that's how I know I did the problem correctly. All right, I've got 2 more examples. In example C, we do actually have to do that step 1. We have some parentheses. We're going to get rid of them. And to get rid of the parentheses means distribute that too. So now I've got 2 times x minus 2 times 3 is 6, and that equals 6x minus 6. Notice anytime I do an operation on an equation, I actually copy down the entire equation. I think that's really important because it helps you kind of keep track of what you're doing. It also makes it a lot easier for the person grading your work, me, to follow your work if you actually write down the entire equation every single time. So this problem now is a lot like the earlier problems. We want the x's on one side, and let's say I want to put the x's on the left. That means I want this 6x to be on the left, and I want that minus 6 to move over to the right. So I'm going to start by moving the x's to the left. So to get rid of a plus 6x, I have to subtract it. And that gives me a minus 4x minus 6. And on the right-hand side, I am just left with a minus 6. Now I'm trying to get that x term by itself, so I have to get rid of the minus 6. I'll do that by adding 6 to both sides. So now on the left, I am just left with a minus 4. And on the right, minus 6 plus 6 is 0. And I do have to write down the 0 here because there are no other terms. You don't have to write down the 0 on the left because it's being added to something else. And so adding 0 doesn't actually change the number. All right, so to finish, I'll rewrite my problem over here. I want to get rid of that minus 4. It's being multiplied, so I have to divide both sides by minus 4. And 0 divided by negative 4 is 0. Don't let the 0 throw you off. It's perfectly fine to get a solution of 0. It doesn't mean you've done anything wrong. It's just another number to work with. All right, one more example. Let's see if we can follow our procedure for this problem. Step 1 is simplify. That means get rid of parentheses. So I'm going to have to do some distributing. 3p plus 3 times 2 is 6 minus 2p minus 2 times 1 is minus 2, and that equals 4p. Notice I had to distribute the negative with the 2. Now that I have a lot of terms on the left-hand side, I'm going to take the time to combine like terms or simplify. So 3p minus 2p would be 1p. And then the plus 6 and the minus 2 is a plus 4. And that equals 4p. To finish, I want all the p's on one side. I've been putting the p's on the left-hand side, but it actually doesn't matter. You can put them on the right-hand side as well. And so I think I'll do that to show you that if you want to put the p's on the right, that means you'd have to get rid of that p on the left. It's a positive 1p. So to get rid of it, I'm going to subtract it from both sides. Now I just have a 4 equals 4 minus 1 is 3p. And then to finish, I want to get rid of that 3. It's being multiplied, so I have to divide both sides by 3. And 3 doesn't go into 4. That's okay. You can just leave your answer as a fraction in this case. P equals 4/3 would be my final answer.